Well, hello, everybody, and welcome to a special Surfrider Foundation online event featuring a discussion about monitoring our rising seas from space with Dr. Shannon Statham. Thank you to Michelle from the Newport Beach chapter for helping to organize this, and you will hear from both of them shortly. Many of you are familiar with the Surfrider Foundation and our work, but just in case you are not, let me give you a quick overview. Surfrider Foundation is dedicated to the protection and enjoyment of the world's ocean waves and beaches for all people through a powerful grassroots activist network. Just admitting some people as we go. Here's a look at our national grassroots network of local chapters and student clubs. I think this is really the biggest strengths of Surfrider. We make a difference locally, and we have been able to scale up our impacts to the state and federal level. And here's a look at the 5 initiatives that support Surfrider's work, essentially what we fight for. So everything that Surfrider does has to fall into one of these 5 categories: plastic pollution, ocean protection, beach access, coastal preservation, or clean water. And really at the end of the day, our tagline is we're all about clean water and healthy beaches. So without further ado, I would like to stop sharing my screen. Bear with me. And sea level rise is part of our coastal preservation work because Surfrider is concerned about the coastal impacts of sea level rise. So I'm really excited to welcome my friend and colleague to talk about that intersection. Please welcome Surfrider's Coastal Preservation Manager, Stefanie Sekich-Quinn.
Hey guys. Woo-woo. Bill, I do have a few slides. I'm not going to bore you. So if you want to let me be a host so I could share my screen. Nice. Okay. So I really just wanted to be super quick about this because we obviously would like to hear from someone as amazing as Shannon, who's just living an amazing world, helping bring kind of progressive new ways to figure out climate change and what's happening. So why does Surfrider care about climate change and particularly sea level rise? It's very simple. It obviously impacts our places where we play. We know that surfing is going to be impacted. Just 3 feet of surfing will wipe out over 80% of great surf breaks in California. We know that it's impacting our diving because of ocean acidification. I'm not going to get into it. You guys all know why we're here. We don't want our playgrounds ruined. And of course, most importantly, what I think is interesting is it's impacting our communities. And I think Shannon's going to be able to share a lot of really good information about this kind of in that regard with her work. So obviously we just kind of went through a little bit of the impacts. Surfrider for the past 5 years has really increased our climate change work because we really feel it's important for us to be on the foreground. We have 1 foot in the ocean, 1 foot in the sand at all times. And so we're starting to see it. When I started working on climate change for Surfrider 5 years ago, it wasn't as visible. We didn't have climate fires like we do and have this summer. We didn't have an increase in all these hurricanes on the East Coast alone and the Gulf Coast. An increase of sunny day flooding or just normal kind of high tide flooding has increased 150 to 200% in the past 20 years. So even just in 5 years, we've seen these impacts. So Surfrider created this little infographic so we can illustrate what our membership and our ecosystems are going through with climate change. And I do have a fun little slide that's words, although we're prioritizing and we're reprioritizing how we do climate change. So we have 3 goals. We want to make sure that we raise awareness about the impacts of climate change on our ocean and coast. Tonight's event is exactly what counts as that. We want to support coastal adaptation practices and sea level rise planning efforts across the country and get in with local communities to help do that. And of course, we're going to continue to fight fossil fuel projects and advocate for greenhouse gas reduction. So again, how do we do that? You guys are doing that tonight. You're doing that through the education and outreach component of it. So thank you so much. Surfrider headquarters has been investing a little bit more time and resources. So we're creating more, collateral, I guess you would say, which we'll see here in a second. We also do a lot of our work through campaigns. That's just a beginning, a middle, and an end. A campaign is a campaign. It's a military term for a reason, right? We have tactics, we plan for it, we have a beginning, a middle, and an end. We do that through sea level rise planning, through fighting fossil fuel campaigns, and obviously all these other kind of shorter, they could be a long-term campaign though, who knows. And then we also do programs, which is not like the beginning, middle, and end. It's a continuous thing that we do. So for instance, our dune restoration work that's primarily on the East Coast and in the Gulf, that's ongoing, right? That's never going to stop with us. And our OFG program, which is our ocean friendly gardens, which helps remove carbon that's in the air. So every time our chapters go home and our chapter leaders take out their grass, they're literally helping with climate change mitigation, and it makes me so very happy. I'm going to show you some of the education materials. It's a 1-minute video, and then I'm going to hand it back to Sharon. I just want to get everyone stoked about continuing to work on it. Newport Beach's got some very interesting flooding situations, which you all know. So when we have king tides coming up, which will be on December 14th and January 10th, if you all can get down there and start documenting it, because it's exactly what Shannon's going to talk to us about, finding the way that these seas are rising, monitoring them, categorizing them, and analyzing them is going to help us protect our communities. So here is our fun little video. That's how we're elevating climate change.
For generations, humans have taken our magnificent planet for granted, falsely believing that our collective actions would not impact the Earth's vast ecosystems.
1,600-page report painting a dire picture. Experts say we have until 2030 to avoid catastrophe.
Unfortunately, the climate is changing faster than our politics. We're in Washington, D.C. right now with the Surfrider Foundation. We've brought over 150 activists from all across the country.
Some from Hilo, Hawaii,
Lake Oswego, Oregon, Florida,
Massachusetts,
Brooklyn, New York.
We're going to be barnstorming Congress and meeting with our congressional representatives at the House and the Senate to urge them to take action on climate change, plastic pollution, and clean water.
We need to come in numbers and come with intellect and creativity, but most of all, passion.
Join us in demanding that Congress takes action on climate change now.
So again, that's just the example of resources that we're creating at the national level. We'll be doing another video this year. We have our toolkit, which talks about all the different ways Surfrider can get involved and is involved with working on climate change and sea level rise. We are going to prioritize this at the 2021 level. We have legislation, we have a bunch of fun stuff coming to really prioritize climate at the national level. And so I look forward to working with you all and sharing all these upcoming resources. And once again, Bill, thank you for inviting me. And Shannon, thank you for your great work. I can't wait to see. So that's it for me.
Awesome. That was great. Thank you very much, Stephanie. Appreciate you being here tonight. Next, let me introduce the Surfrider Foundation Newport Beach Chapter Chair, Michelle Jerome, to talk a little bit about the Newport Beach Chapter and introduce our guest speaker. Take it away, Michelle.
Hi, thank you so much for joining us. This year has been very different, so I normally invite you to a beach cleanup, but we are suspending those again. So we encourage you to go to our website. I put the link at the top with some other links, and check out our solo beach cleanups page and maybe do a cleanup in your neighborhood or at the beach on your own, and send us back some data on what you find, because every bit makes a difference, and it makes you more aware of how our actions affect the environment. So Bill already gave an introduction of Surfrider Foundation, so I'll just go ahead and introduce our speaker. Dr. Shannon Statham is a system integration and test engineer at NASA's Jet Propulsion Laboratory in Pasadena. She joined JPL in 2011 after earning a bachelor's degree at University of Central Florida and a PhD at Georgia Tech, and both are in aerospace engineering. At JPL, she worked on several flight projects, including the recently launched Sentinel-6 Michael Freilich satellite. For this project, she served as the integration and test lead for AMRC, which is one of the science instruments that enables the precise height measurements of the Earth's oceans. She's also worked on a number of CubeSat missions, and her roles include project manager for RainCube, which is the first radar demonstration on a CubeSat, so that's a satellite, and flight system integration and test lead for MARCO, the first deep space CubeSat mission. She currently serves as group supervisor for the Environmental Dynamics Test Lab, which operates and maintains the facilities that qualify flight hardware for launch. In her spare time, Shannon blogs about her journey in aerospace. So that link to her blog is also in the chat at the top. Please welcome Dr. Statham.
Thank you, Michelle. Hi, everyone. I'm really glad to be here. Thank you all for joining us. And let me start sharing my screen. Okay, share. Let's see, I think this worked. Now let's get that presentation mode. How's that look? Everyone can see that? Okay, excellent. I'm seeing head nods. Perfect. Okay, and for I'm going to go through my presentation, but if you have questions, feel free to put them in the chat, and we'll be happy to field them afterwards. So this is my talk, monitoring our rising seas from space. And first, I did want to give a little bit of background for deep diving into the Sentinel-6 mission and what that is all about. So I'm Shannon Statham, your speaker today, and these are just two recent pictures that I had. One is just me, at my house earlier this year, and the other one is what I look like at work sometimes in a bunny suit. And what's actually behind me is the Mars Perseverance rover, which is currently on its way to Mars, scheduled to land in February of 2021, and it was undergoing a test back in 2019. So that was a fun picture I got. But I'm from Jacksonville, Florida. So the other coast. I heard at least one person on the line from the East Coast, but born and raised in Jacksonville. And you follow the NFL, home of the Jacksonville Jaguars, and also known for our riverside views. But that's where I grew up. And then for school, I went down to Orlando, Florida, and got my undergrad degree at UCF in Orlando, and then went up to Atlanta for graduate school at Georgia Tech. So I primarily have lived on the southeast side of the United States. And then in 2011, I hopped over to this coast, to the West Coast, and joined JPL. And just in case anyone didn't know this, the 10, or Interstate 10, actually spans the entire continental United States. So it was just always really amusing to me to think that I was born and raised at the dead end on the east side, and now I'm living at the dead end on the west side of that interstate. And I'm not a surfer, but I do scuba dive. I'm a certified scuba diver, and it was always just really fun and interesting to go from the warmer tropical waters of the Atlantic Ocean to now the colder but just really beautiful kelp forest and the sea lions and the wonderful marine life that we have out here on the West Coast, and just really fun, and always love the oceans. So what does a system integration and test engineer do? It's not something you necessarily go to school for. So I thought I'd talk a little bit about that. But essentially, what I do and what my team does is we're responsible for assembling and testing the flight hardware, the satellites, and these instruments, these science instruments, before they get launched into space. And so we're all about, making sure that we've got all the pieces are coming together, they're playing nice together, they're operating and performing the way that we need to. And we also qualify them for space. We qualify them to make sure they're going to survive launch and that they can survive and operate in their mission environment, whether that's orbiting Earth, landing on Mars, or going into deep space and exploring other planets. That's our job. And here are just some fun pictures. The one on the left was actually me with the instrument that's on Sentinel-6 that I worked on. And then it was mentioned CubeSats in my bio. So CubeSats are essentially miniature satellites, the size of a shoebox. And so these were two of the missions that I had worked on. So you kind of get a sense that we, at JPL and NASA, we work on hardware that's can fit in the palm of your hands to things that are the size of a bus and everything in between. And I'm also now the group supervisor for the Environmental Dynamics Test Lab. which is responsible for operating and maintaining these great facilities that we have at JPL to qualify our flight hardware for launch. So again, there's that picture with the rover behind me. So that was, we were literally shaking the rover to make sure that the vibrations it would experience during launch was not going to cause any damage, or the rover wasn't going to have any issues operating after that event. And the one on the far right is actually the rover getting tested under a thermal vacuum chamber, which is my sister group. So where we certify for launch, they're certifying for the extreme temperatures and pressures and vacuum of space. So fun stuff. So a little bit of background about JPL, just because sometimes when I meet people outside of my work, they don't immediately catch on to what is JPL. But then as soon as I tell them, oh, we're the ones who put rovers on Mars for NASA, it immediately clicks. They're like, oh yeah, you guys, I know you. But we do have a really interesting and unique relationship with NASA. So JPL is a federally funded research and development center, FFRDC. And so essentially we are contractors to the federal government, and our primary customer is NASA. And then it's just, there's an interesting relationship there. So the land and all of the property buildings, it's owned by the federal government, but Caltech manages JPL. And so all of the employees, including myself, I'm a Caltech employee and a government contractor. So just in some ways we operate very similar to a NASA center, and then in other ways very different. So it's really, really interesting relationship. But as a lot of people know, we land rovers on Mars, and one's on its way there now. But we do have a long, long history of space exploration. JPL was founded in 1938 by some Caltech students who wanted to play with rockets, and basically established what is now known as JPL. We were responsible for getting the first US satellite into space, Explorer 1, in 1958. And then I just kind of picked out some key missions that I think a lot of folks are familiar with. We had the Voyager 1 and 2 missions, which are still in operation. Just insane to think we launched that in the 70s and they're still out there and operating. We had Cassini that was exploring Saturn and recently ended that mission. And then we've got the Mars 2020 rover mission on its way. But kind of funny thing is a lot of people think of JPL and NASA and they think Mars, they think deep space, they don't think Earth. But we actually have a lot of Earth science missions, missions that are dedicated to exploring and better understanding our planet. And in fact, up to 25% of JPL's annual business on average is dedicated to Earth science projects for NASA and our government. So that's actually quite a bit. It's a not trivial amount. In fact, most of my career has been on Earth science missions. So we do a lot. And one of the first Earth observing missions that was launched was CSAT back in 1978. And JPL was involved in that. And we've got a number of operating satellites right now. Jason 3 is the predecessor to the Sentinel-6 mission. OCO2 is monitoring carbon. Our carbon footprint from space, and RainCube was one of the CubeSats that I worked on, and then now recently Sentinel-6 Michael Freilich is in orbit and operating. And now I do want to talk about this legacy that Sentinel-6 is continuing for monitoring our seas. Okay, let's see. So it's all started back in the early 90s. In 1992, NASA and CNES, which is the French space agency, joined together and launched TOPEX Poseidon. And that was that was basically the first mission of this legacy that Sentinel-6 is continuing. And it was measuring the ocean heights to an unprecedented accuracy, less than 5 centimeters. That's roughly 2 inches of accuracy that we were measuring, how high the oceans were around the globe. So really getting that global map of our ocean heights. It was also one of the first full maps of our tides, and also helped scientists, really monitor some of these phenomena that were happening in the 90s, like El Nino and other really interesting events. And this mission that was originally planned for, I think, 3 years with a possible for a 5-year extension, ended up going for over 13 years. So it was really, really incredible mission. And we've kept it going. So we have now had 28 years of continued observation of our ocean heights and really understanding how our sea levels are changing, where they're rising, falling, and what is the long-term effect that we're really seeing. So before Topex and Poseidon finished, we launched Jason 1, and then we've had Jason 2 and Jason 3. Jason 3 is still in operation. So we're gonna have a little bit of overlap with Sentinel-6 Michael Freilich, but you see that we're almost now at 3 decades of really measuring these oceans and really understanding what's going on. But one question we get sometimes is how do you measure sea level from space? Like, how does that work? So I wanted to just give a quick overview. There's 3 key elements to every single mission that we've had in this legacy. And the first is a radar altimeter. So if you think of the radar that police officer might use to measure the speed of a vehicle, it works a lot like that. It's sending a signal and then to a target, which for us, it's the ocean surface. And then that signal reflects back to the satellite. And depending on how long it took for that signal to return to the satellite, that tells us exactly how far away the surface of the ocean was. And that tells us, its height. But what happens is we're in space. So as we're flying over, there's clouds and other forms of precipitation like rain and snow that actually cause a delay, a slight lag, if you will, in the radar signal getting down and bouncing back up. And so in order to resolve those delays, we use what's called a microwave radiometer. And that was the instrument that I worked on for Sentinel-6. And so the microwave radiometers are tuned specifically to capture the water vapor in the atmosphere. So any form of water vapor that's in the atmosphere, it's going to pick it up. And then we use that data along with the radar data. And that's how we're able to resolve these very precise sea level heights down to millimeter levels, which is really, really small. And then of course we need to know exactly where we were. Where was the satellite when we took that measurement? So we can get this really nice global map. And as we keep getting these measurements, we know we were looking at the exact same spot every time to compare those measurements. And so that's where we end up with needing these sophisticated global positioning instruments. And this is just a nice animation. So the red dot showing you the radar, the blue is showing the radiometer. So just a nice little visual. And what is the data showing us? So 28 years, almost 3 decades of data, sea levels are rising. Stefanie, you gave a really great introduction into this, but I mean, you can't deny the data. It is rising. And not only is it rising, it's rising at an increasing rate. When Topex and Poseidon started taking measurements in the early 90s, we were seeing roughly a 2 millimeter average increase per year. And now in recent years, we're seeing greater than 4 millimeters. So if you can just appreciate that, I mean, I know a millimeter doesn't seem like a lot, but just imagine in less than 3 decades, we're seeing more than double a rate and increase in our sea level rises on average around the globe. And, in 1 year, that might not seem like a lot, but in a decade, that's 2 inches at least. And then in 50 years, we're talking almost a foot of increase across the globe on average. And that's an average. So that means in some areas, it's going to be worse. It's going to be even higher. And in this map here in the bottom left, kind of gives a nice, a visual of, where you see red, that's where things are, a lot higher than that 4 millimeter average per year. So yeah, it's they're rising and that's what the data is showing us, and we're seeing increasing rates consistently. And what does this have to do with climate change? So measuring sea level rise is one of the most visible, indicators we have of global climate change. And that's because our oceans act like a reservoir for all the heat that's being trapped, right? All our warming planet. So you hear about glaciers melting, ice sheets melting. Well, that's just that liquid water is now creating, a rise in our oceans and expansion. Also, 90% of the heat from greenhouse gases that are trapped in our atmosphere end up getting absorbed by the oceans. And so when when things heat up, they expand. And again, just adding to that overall sea level rise. And as Stefanie also mentioned, we're starting to see these more extreme events. As the oceans are warming, we're going to see more hurricanes. We're going to see more extreme events like flooding and drought and wildfires. And so as climate change continues, we're just going to see these effects more and more. And then coastal erosion. That's another, so 40% of the world's population lives near a coastal line. And so we're just, as these sea levels are rising, those coastal lines, those, people's homes, people's businesses, the playground, as Stefanie mentioned, like they're eroding, they're going away. And that's a big deal. We need to, look at that and see what we can do about it. So now to the mission, Sentinel-6 Michael Freilich. So how this mission came to be. So as you saw on the previous slide, there were these JASON missions. And so it was basically a combination of the JASON missions from the NASA side. And JASON CS just stands for continued support. So why it's not 4, don't ask me. I don't make I don't make the name decisions. But it was basically JASON continued support combined with the European Union Copernicus program, which actually one of their Earth science programs that they've launched. Looks like 6 Sentinel satellites. And so these two programs married for Sentinel-6 Michael Freilich. And it's actually the first Earth science mission collaboration between NASA and ESA. We've done a lot with ESA, and obviously our past programs were with CNES, the French space agency, but this is actually the first time NASA and ESA combined for an Earth science mission. And we've got many other international partners, including UMETSAT, and then also NOAA is a federal US federal organization that we team up with often for these types of missions. So what's different about Sentinel-6? Well, first off, we're always trying to utilize the latest technologies to get even better data than we've been able to in the past. So Sentinel-6 is right up there, and we're going to get the most precise measurements that we can. And so a single measurement is going to give us accuracy down to about 3 centimeters or roughly an inch. But as we take these measurements over and over again over the life of the mission, by taking averages, like we're able to get even more precision down to millimeter accuracy within a year. So that's how we're able to resolve that. Oh, we're seeing 2 millimeter, 4 millimeter, 3 millimeter rises. That's the level of accuracy we're able to get by continuing these observations. And also we're going to get better resolution at the coastal lines. So what does that mean? In the past, when we're over the oceans, we get these really nice, accurate measurements. But as we were getting closer to the coastal lines, things got a little blurry. They got a little gray. The resolution wasn't quite where we wanted it to be. So on AMRC, on the microwave radiometer instrument that JPL built, my team assembled and tested, actually has a component on board that will enable us to get those same precise measurements that we get over the oceans to the coastal lines. Again, the areas that we really care about. We also have a new onboard calibration system. These are all adding to, getting even better data than we've been able to in the past. And we also have a new instrument that will get weather, basically it'll get temperature and humidity measurements of our atmosphere, and that helps weather forecasting. Those are temperature and humidity in the atmosphere are key elements to weather forecasting and climate models. So that's another instrument that we have on board that's going to contribute to that work. And then finally, we have 2 satellites. So, giving, NASA and ESA, we're looking ahead saying, what, we've been flying these satellites, constantly every 5 to 8 years. It would actually be a lot more cost effective and efficient to just build 2 at once and basically fly them in series. And so that's exactly what we did. We built these 2 satellites back to back. The first one flew, launched 2.5 weeks ago, Sentinel-6 Michael Freilich, and its sister, its twin, will fly in 2025. So that's going to give us a decade long's worth of ocean, height measurements from this mission. And then this is just a picture of my team. This was in 2018, so pre-COVID. So that's why people's masks are down and we're very close. Yeah, this is my team at JPL, and that's our instrument AMRC. And as I mentioned, integration test, it's all about assembling and testing this hardware, making sure that it's going to function and perform the way that we need to. And yeah, we delivered the first instrument in early 2019, and then the second instrument we delivered in November of 2019 for the project. And sorry, I'm not sure if you guys, since I'm a host, I keep getting these little pings. I hope you guys can't see that, or at least it's not distracting. So why is it called Sentinel-6 Michael Freilich? That's kind of an interesting name for a mission. But actually, Dr. Michael Freilich was the director of the Earth Science Division at NASA for many years. And he was key to this mission and many other Earth science climate change missions. And also a huge advocate for international collaboration. So if it weren't for him, a lot of these missions just wouldn't have happened, or certainly wouldn't have been as successful. And so this was honoring him. And unfortunately, he did pass earlier this year. He lost his battle with cancer, but it was just really just amazing that we were able to honor him in this way. If you guys are familiar with space history, very few missions have been actually named after someone. And so this was a huge honor that we were really privileged to be a part of. And this is launch. So for folks on the West Coast, if you've ever tried to see a launch from Vandenberg Air Force Base, which is up in Lompoc, it really is hit or miss. This area is notorious for its marine layer that just creates this big fog. And I have tried to see a launch in the past and it was a bust. I couldn't see, I could hear it, but I couldn't see anything. And we were just, I was blown away with how beautiful the weather was for launch, and just really wanted to share this with you guys. So this is my video, my iPhone. So it's not the best video in the world, but hopefully you can hear the sound. Oh, let's see.
0. And liftoff of Sentinel-6 Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all of humanity.
So yeah, just picture perfect launch.
And when the proportion is nominal.
What's the speed right now that it's going at?
Oh, that's a good question. I do not know the speed. It's really fast though.
It's so cool.
Yeah, I mean, the vibrations you feel from a launch, it's intense. It's really intense. And then what was also really neat is, so for folks that are familiar with the SpaceX launches, what they're doing now is they're actually returning the first stage boosters so they can be reused, which is really amazing. And so it was really cool is this was actually, I believe this was the first land return of their boosters on the West Coast, excuse me. So that was really neat. And you'll hear in this video, you'll hear two really loud like pops, and that's actually firings that happen when they're trying to bring the booster back down and land it safely. And it's just, it's really, really cool. Yeah, that went off very, very well. Okay, so what's next? So NASA's mission continues. Obviously, we just launched Sentinel-6 Michael Freilich. We're currently commissioning the satellite. So that's where we, power everything on, check it out, make sure that it's operating as expected, and then we go on with our prime mission. and we're planning operations through 2025. But hopefully, if you've seen our past successes in this series, we've always done more than 3 to 5 years. So we don't expect anything less from Sentinel-6 Michael Freilich. And then we've got the second, the twin that'll launch in 2025. So that'll give us these measurements again through the end of the decade. We also have 2 other missions that are currently, in their integration and test phase. So we're building and testing them right now, and should be launched within the next 2 to 3 years. And that's SWAT, which is another NASA and CNES collaboration that will be part of this bigger legacy, measuring the ocean heights as well as some other interesting earth science applications. And then we have a collaboration with the Indian Space Agency called NISAR. So we're just, these are science missions. They're going to continue, because that's really important. And, just in case you want to learn more, so sealevel.jpl.nasa.gov will give you everything you ever wanted to know about Sentinel-6 and this legacy of ocean observation missions. And this is also could lead you, so all of the data that we collect from these missions are publicly available, which I think is really important, because not only does NASA want to get this data and analyze it, but we want it to be available to the public for their own use, for their own applications that they might have, and just to be informed. And so this site will also lead you to that publicly available data if you're interested. And then if you do want to know more about me, I blog about my adventures in aerospace at statum.space. And yeah, and I just want to end with, I really love Stefanie's intro. It was just really amazing to learn more about your organization, and how important, the oceans are, our planet is. And I feel the same way, JPL and NASA, we're known for the space exploration. We're known for, exploring the other planets and answering the really interesting questions about our universe. But it's so important that we also, study our planet. It's the only home that we have, and we need to take care of it. And so I'm really just honored to be a part of this mission and the Earth Science mission at JPL and NASA. And thank you very much.
Awesome. Thank you, Shannon.
Thank you.
Okay, I promise I won't hog everything, but I swear I'll limit myself to questions. So what other practical ways can people and entities and whatever agencies use this data? There are ways that we can extrapolate it in a different way for policy recommendations. Like, just curious what you hear when you're doing this work and where people are like, yes, I want that data because of X, Y, and Z. So the usage of data, and the different places it could go.
Yeah, so I mean, the usage of the data is really broad. And some applications are just beyond what we ever could have expected. Our project manager mentioned for, I think, the JSON-3 data was used for trying to locate the Malaysian airliner that went down. And they were like, could we maybe use that data to see? I've gotten a lot of questions about tsunamis and if there's an earthquake over the ocean, can Sentinel-6 pick that up? And we might not catch it real time, but any effects of the changes to the oceans, absolutely, we're going to be able to pick that up. So I think the usage is as imaginative as we all can be. And I think it's just important that we make it available so that folks can use it and extrapolate whatever information they think that they can from it. At NASA, we're specifically looking at sea level rise. We're taking that data and saying, what is happening to our sea levels, and what is the trend? Because that's really important. By looking at the trend, we can better predict what it's going to look like in the future, 10 years from now, 20 years from now. And so that's what we focus on, but the data can be used in many other ways.
Yeah, that's great. It's so fantastic.
I have a question. Thank you, Shannon. I am a Caltech alumna, and I'm super excited to have Michelle and Amar Bold on here. Maybe some other people are Caltechers, but anyway, this is very exciting. My question is, so Surfrider, and I'm not sure it came from Surfrider, but there's a smart fin technology for fins on surfboards that can do ocean readings. And it hasn't quite totally gotten widespread, right? But it's a promising, you know, a promising technology. And I was just wondering if like there's any way to integrate what you do with what the surfers do. I mean, an idea. So.
Yeah, no, that's interesting. Well, I can say that at least from NASA's perspective, you know, a lot of the technologies that we develop to complete these missions end up in the public domain, right? I mean, it's really amazing to think about some of the things like prosthetics. Like a lot of the advancements in prosthetics, a lot of, I think braces, your tempuric mattresses or whatever, that was for the space station. I mean, it's really kind of interesting how with JPL and NASA, when we work on new technologies to make these missions possible, those technologies end up going into, you know, the public domain and can be used for many things. And I don't know anything specific about these surf fins. But, you know, we also have really interesting collaborations with airborne demonstrations and looking at coral and stuff like that. So we definitely have some, more hands-on, not necessarily in space activities that are going on with NASA and JPL. So I think collaborations are definitely possible.
So just quick, I want to say about the smart fin. Yeah.
Stephanie and Bill, one idea is like, let's figure out how to integrate, and Michelle, and let's figure out how to integrate SmartFin with what Shannon and, you know, this whole mission is doing. That would be awesome.
Yeah, we'll send you a link to it, Shannon. I don't want to steal, but we have been working with scientists at Scripps on the SmartFin, and part of it was what you were saying, because a lot of images from satellite kind of blur out when they get in the coastline. So the inventor wanted to have something that was in the coastal area, but buoys, as you know, don't fare well in a high energy impact zone like that. So the SurfFin, it's interesting. I'll send you some more information. Because of COVID, just the manufacturing of it's not where we want it to be, but it does GPS, salinity, acidity, and oxygen.
Mm-hmm. Awesome. Yeah, definitely send me the information.
Hey, Shannon, everything looks super smooth with the launch and the operation, but I'm sure there are probably some hiccups along the way. Could you maybe touch on like some challenges with the project?
Sure. Yeah. So, I mean, every project is going to have its own challenges because, one thing at JPL and NASA, we can never do the same thing twice. It's just not in our nature. We're always like pushing the envelope, pushing those boundaries to make these missions happen and to get the most, valuable data that we can. I think for Sentinel-6, we try to think if there was anything. The one thing that was really complex, I feel, for our particular task in the mission, so this radiometer, I mentioned that one of the new things was an onboard calibration system. And so what is that? So if you think about like your clocks in your home, you reset them for daylight savings, and then, a couple months later, you notice your microwave clock is not quite what your oven clock is saying. And then you got to reset them, to make sure they're saying the same thing. So we have to do that a lot with our science instruments and during our missions. We have to recalibrate them and make sure that the data is as good as we expect it to be, make sure we're getting that same quality throughout the months and years that we're in operation. And a new science requirement that was actually part of the Sentinel-6 program that wasn't part of its predecessors, it basically required, this onboard calibration system so that we could more accurately calibrate the radiometer throughout the mission. And that component ended up having a rotating mirror. And I hope anyone can appreciate that when you take something and you start adding moving parts to it, it just becomes significantly more complex. The testing campaigns become, significantly more involved, because now you're talking a mechanism that you need to move, not only move and test, but it's got to work in space. And so you got to think about what greases can go into space. And so, that was a big challenge. But, fortunately we had some really good, partners to build that system, and then my team assembled it to AMRC, and everything ended up working out okay. But it's it was making sure that we had the right set of people working on it, and getting the right design and the right test campaign to know that it was going to work for us.
Excellent. Awesome. Thanks.
Yeah.
If anybody else had any other questions, feel free to unmute your mic, speak up.
Oh, I'll ask a question. This might be like, this is for people who don't know what it's like to work in one of the clean rooms. What is a day like when you're in there, and how many hours do you spend?
Yeah. So, well, fortunately for us, so there's kind of different levels of clean room. And maybe you guys have seen this in the movies, but there's some levels where you're full on bunny suits. So that, I don't know, maybe I could go back in my presentation and show you guys, but there are different levels depending on the mission and where it's going. But if you go back to, yeah, actually this would be a good picture, I think. This one here. Sorry, one second. There we go. So for Sentinel-6, we were in these smocks, and we had our hair nets and a face mask and these booties. But we could wear like our regular clothes, and some of it was exposed. But because we're Earth science, so we're not going to another planet, so we're not so worried about like planetary protection and bringing our bacteria to some other planet. And we weren't an optical instrument. Optical instruments tend to be very sensitive. So this is what it is. And I mean, we gown up just like you put on your clothes every day. We put on this lab coat and the gloves and everything. And then we'll be in the clean room the full day, but we definitely take breaks. You got to take breaks, every couple of hours to food and hydrate and what have you. But when we're in the high bay, when we're in the clean rooms, we're there all day. But as I mentioned, but if say you're going to Mars, so you guys see some good pictures here. These are what we call bunny suits. So they're like, it's a full on jumper. And our gloves are taped shut. So there's no way the glove can accidentally like move up and reveal skin. And you can see clearly the head, the hood, it's a hood, and it's a whole nother ball game when you're going to deep space, especially something that you're going to land on another planet, because we're really big on planetary protection and making sure that we're not taking our own, germs and bacteria to a planet that we want to see if there was life there. That would be disappointing if we find life on Mars and it ended up being ours. So that's kind of the different extremes that we have. And I think this person here actually, because we were shining down light in this chamber, it's really cool. It's actually a solar simulator. So we can simulate like the luminosity of the sun. And so he was kind of taking measurements around the rover to make sure that it was getting the right intensity at different places. And so he needed like even more protection for that activity. So
I bet you guys were really good with all the COVID protocols when we all had to start.
Yeah, actually that's definitely been a plus for us. Is the clean rooms are very clean. They've got really good airflow, like by design, we've got these HEPA filters that are just amazing. And so in that sense, it makes things very safe for us to continue our work. JPL definitely, like everyone else, we came to a full halt and had to evaluate the risk and make sure that it was safe for our folks to still come on site and continue the work. So we have been working at a much reduced capacity, but for a lot of the work that we do, the building and testing, you can't do that from home. So we do have to go on site, but we do it in a way that we, very much minimize the risk to everyone, and the clean rooms certainly help.
So I have a question. I know I appreciate, Shannon, that you're a scientist, and I'm wondering about people on your team that are the policy experts, if there are any. So to interface with Surfrider and our goal to protect our well, not just our playgrounds, but our world, and how we can partner more. Or who is the person, if it's not you, maybe it is you, but who are the people at JPL that Surfrider should be interfacing with more to bring this information and these really compelling images to a broader network of people, so that maybe information will get into people's minds and it might change them about climate change and sea level rise.
Yeah, so I mean, I know at least for NASA and JPL, right? Our primary objective is to get the data, right? To get objective data that you know is say this is what it is. This is reality. This is what's happening. You know, you can't deny the data. And then to make it publicly available so that policymakers and you know, and the general public can then use that information and hopefully do what is best for the health and future of our planet. And you know, at JPL, I wouldn't know offhand any context, but we can talk offline. But you know, the only other thing I can say is the best thing that we can, you know, say for the general public is vote for science, vote for Earth. I mean, you know, we're giving this data, you know, NASA is the NASA and federal government are our customer. We give them this data and we say, you know, do what you will with it, but this is the data. So then it's in their hands at that point. We don't make policy. So then the only other thing we can do is vote for the people that are supporting the policies that are going to, you know, improve things and prioritize our planet.
All right, we're near the top of the hour. Any last questions before we wrap up?
That was awesome. Thank you so much, Shannon. It was so wonderful to learn all this information.
Yeah, no, thank you so much for having me. This is a lot of fun. And hopefully you guys learned a lot about the mission and more about what JPL actually does with Earth science. I think that's always a fun surprise for people. They're like, wait, you guys do Mars rovers. What are you doing Earth science? But we actually do quite a lot. And it's really awesome that we get to be a part of that. And because we're part of JPL, because we're part of NASA, like this is all public. It's all publicly funded. It's all publicly available to you guys. So definitely check out the website and learn more.
And look at all the pretty images too. Yeah.
Yes. There's lots of beautiful images there. Actually, I think I pulled most of them from there. So, yes.
Nice. All right. Well, thank you, Stephanie. Thank you, Michelle. Yes. And thanks again, Shannon. We really appreciate your time, everybody, tonight. Thanks for everybody who joined us. We appreciate it as well. Stay safe out there. Happy holidays and hope to see you in the new year. Take care, everybody.
Thanks, Bill.
Bye. Thank you so much, Shannon.
Bye. Thank you. Really appreciate it.